Hi class, in this video we're going to be talking about patterns and linear relations, and we're going to start with definitions. So the first term we're going to define is called a constant. A constant is just a number. So an example of this would be the number 2, 5, 8, or 9. These are just numbers by themselves, so they're constants. You can also have negative numbers as constants, so -4. That can also be a constant. Now, variables are just letters that represent an unknown number. We can also use symbols to represent them, but for simplicity, we're going to use letters. So an example would be X, that's a very common example, Y, A, C, and K. These are examples of letters used to represent an unknown number. A coefficient is a number that multiplies the variable. So an example of one could be 2 or 6 or maybe like 10, right? So if it's a number that multiplies a variable, how I can write it would be, it'd be 2 times, and let's say I let the variable be x, 2 times x. However, to make this more simple, we can just write this as 2x. And the reason being is because in algebra, when instead of writing the multiplication symbol, if we want to multiply a coefficient and a variable, we just write the number right next to the variable. And it just implies that it multiplies together. And also by convention, we like to write the number first and then the variable afterwards. So instead of writing this as x2, we write 2x because the numbers should come before the variables. And if I had multiple variables multiplying by a coefficient, let's say I had 2bca, I would actually rewrite it as 2abc because afterwards the order of the variable, we like to keep it alphabetical as well. Yeah, so that's an example of a coefficient. Another one would be, let's say I had -6 times y. I would just write that as -6y. And it just implies that I'm multiplying -6, which is my coefficient, to the variable, which is y. Now, a term is just a single constant, variable, or coefficient and variable. So examples of a term could be just the number 6, the variable y, or a coefficient multiplied by a variable. So we could say 3c. Those are just examples of terms, but they're just a single one. So the term could either be 6y or 3c, but it can't be these combined together. An expression is a single or combination of operations using plus or minus that involves terms. So now an example of an example could have multiple terms. So an example of an expression could just be 6. I could just leave that. That could be called an expression. Another example could be 6 plus y. That could be an example. Now I have two terms together. Notice for an expression I could have multiple terms involved. And another example could be 6 plus y minus 8d. That is also an expression. In this case, I would have three terms, but I can have multiple terms in an expression as long as they're separated by plus or minus symbols. Now, moving on, we're going to talk about an equation. An equation is an expression, but the only addition is it has an equal symbol. So an example that I had before was I believe I used 6 up here. So an equation could just be y equals to 6. That's an equation now because I have an equal sign. Another example could be, here I had 6 plus y. So if I just put an equal symbol here, let's say I say that equals to 10. That's now considered to be an equation. And if I had 6 plus y minus 8d, that's an expression right now. As soon as I add an equal sign or symbol, and then I write something down, let's say I write 26x. Now that's considered to be an equation. So now moving on, a pattern is an arrangement of shapes, colors, numbers, letters, words, and so on, for which you can predict what comes next. So if I, for example, had this expression here or this pattern here, let's say I had 2, 4, 6, what do you think comes after 6? Probably 8, right? Because it looks like I'm skip counting by 2. So that's an example of a pattern. Now, a relation is a pattern formed by two sets of numbers. So let's say I have, and these usually relate to table of values, but let's say I have a figure here. We'll call this figure 1, figure 2, figure 3, and so on. And let's say in the first figure I have just a block. And then in the second figure I have a block that has 1 added to the top and the right of it. In the third figure I have a block that looks like figure 2, but it looks like I have yet another block added to the top and the right of it. Looking at this here, looks like if I turn this into a table, which we're going to talk about afterwards on the bottom here, I'm going to have, let's call this, let that be X, let that be Y to represent it, figure 1, figure 2, and figure 3. Now it looks like how many blocks are in figure 1? 1. How many blocks are in figure 2? 3. And how many blocks are in figure 3? 5. The pattern seems to be, if I find figure 4 now, as the figure number is going up by 1, I'm increasing my number of blocks by 2. So the next number of blocks in figure 4 should be 7 in this case. So that's a relation. And a table of value is just a table showing two sets of related numbers. So this would be an example of a table of value. We can also write a table of value vertically, like this as well, where I have X and Y, and then I would just still write the same table out, and I can still relate it. So a table can be horizontal or vertical. It's truly up to preference in this case. So now moving on, a graph is a visual way to show how two sets of numbers relate to each other. So on a graph, we would have, let's say, X and Y. X is typically, coordinates typically look like this, and X is typically horizontal, and Y is vertical. So horizontal is left and right, vertical is up and down. In terms of my coordinates, typically I start at an origin where the point is going to be 0, 0, and I would just take points from a table of value and place them onto the grid here. So if I were to place this onto a grid, 1, 1, that looks like it's approximately here. 2, 3, so I go across by 2, 3 up, or up by 3, or sorry, I go across by 2, up by 3, yeah, it looks like this. And then I go across by 3 and up by 5, it looks like this. And then you would notice that this forms a straight line, and that's leads into our next thing, which is linear relation. So a linear relation is a pattern made by two sets of numbers that results in points along a straight line on a coordinate plane. So the linear relation would be the grid that we had, and it would just form a straight line as the pattern here. And that's what a linear relation is, and that's how it relates to a graph. So notice you have to first figure out the pattern, then form a relation with it, then put it into a table of value, then use that table of value to plot points on a graph. And then that, if it's a straight line, that's considered to be a linear relation. And we're going to talk more about this in the other videos. Now the last one is ordered pair. So I kind of talked about it briefly over here. But an ordered pair is in the form of X comma Y. And again, X is horizontal, meaning we go left to right, and Y is vertical, so we go up and down. So when we plot something, let's say I had the point 1, 4, right? And then I have a grid here. X is horizontal, Y is vertical. This is my origin of 0, 0. Because X comes first, and it says 1 here, I would move 1 to the right, and then I would go up by 4. So my point for 1 comma 4 would be here. And that's called an ordered pair. And as you can see from this table of value, if I were to take ordered pairs from this table, it would be 1 comma 1, 2 comma 3, and 3 comma 5. And again, we'll talk more about this in the other videos. And that's it for the definitions.